What is Cross-Site Request Forgery? So you've probably seen forms like this before that ask for your name and your email address. They're all over the web and you use them for just about everything. But so when you type data into one of these forms and click the submit button, the data is sent to a web server of some kind. And the web developer or whoever makes the website can define where that data is sent. And they do that using an action attribute on a form. So don't worry too much if you don't understand HTML, but it looks a little bit like this. This is what's called a form tag, and here is the action attribute. And hopefully this URL path should look vaguely familiar. So that's how they define where the data is sent. So that location that's specified as the action, there is some software that's expecting that form data, expecting to receive it. And it might do a variety of different things with that. It might save it into a database, maybe send an email, or maybe it'll just do some processing with it and return the results to your web browser, if it was maybe a calculator or something like that. So one important piece of information is that a form's action can be set to any website, not just the website the form is on. So you might wonder where the problem is, or perhaps you spot it already. Well, if you're using a website you trust, I think it's fairly safe to assume that the forms there have been configured to send data only to that website, or maybe to trusted third parties. So you wouldn't think twice about putting in your username and password into the login form on Facebook or Twitter or something like that, because you've already decided to trust them with that data. You probably wouldn't put your username and password into a form on stealyourpassword.net, hopefully at least. So that's okay. But forms are used for more than just logging into websites. They're used for modifying your account details, placing orders on e-commerce sites, initiating transfers on your bank website, and pretty much every other situation where a user needs to provide some kind of input. So here's how the attack works. Imagine this is a form on your bank's website, and you're logged into your account, so you can see all of your account details and everything. So there's a destination account field that's expecting an account number, and there's an amount in GBP. You click the transfer button, and the transfer is initiated. That all seems fine, because it's on your bank's website, and hopefully, at least, you can trust your bank. So the issue, though, really isn't actually with the forms themselves, it's with the bits of software that have the data sent to them. They don't really know if they're receiving data that was sent by a legitimate website, like your bank's website, or a malicious one. So what would happen if, say, the owner of evil.com put a form on their website with the account number and the amount pre-filled in, like this one here? They could set the action to be your bank's website. So here we have the action set to yourbank.com/handle-transfer, which is where the piece of software that handles transfers would be running. If you happen to be logged into your bank's website and click that transfer button, then you may well have just lost a significant sum of money. And really, you would have fallen victim to what we call a Cross-Site Request Forgery attack, or a CSRF attack. And actually, it gets even worse than that. So you don't need to really interact with this form and click the transfer button. In fact, you don't even need to see it. Forms can be hidden and they can be submitted automatically. So even just an action as simple as loading a page can be enough for an attack like this to work. So it's not all doom and gloom, thankfully. There is a very good defense for this that your bank has almost certainly implemented. And here's how it might work. So the general idea is, every form that's on their website has a special hidden value attached to it, and it's often called a CSRF token. It might look a little bit like this. This is an input field which is hidden, so every element in a form that you type something in, we call an input element. And it might have a value that looks like this, and this is just a load of random digits. The important thing here is that it is hard to guess, specifically hard for an attacker to guess. The other important thing here is this token is specific to you, specific to the person who loaded the page. No one else gets that same token, and indeed every time you reload the page, you will probably get a different token too. So whenever you submit a form that has one of these CSRF tokens in it, it's sent along with the data that you typed in. The server that served the page in the first place remembers that token and remembers that it's associated with you. And because of that, when you submit a form, it can compare those two tokens and make sure that they match up. And if they don't, it can reject the request. So this works because an attacker can go and load, say, your bank's website themselves and get their own token, but that token is specific to them. So it wouldn't work in the attack scenario we described before because they would need a token specific to you and they're not able to see them. There are other things that can be done to improve form security, but really CSRF tokens are often considered to be the most important or the main first line of defense. I hope that cleared some things up for you.